Right. Lastly, we talked about total internal reflection, right? And I gave you the conditions. I gave you the conditions for total internal reflection, right? Can I show you it here? Anyway. All right. Let me see if I can just load it fast here. Right. What's it here? Right. Normally, if I were to allow a ray, right, to go from air to water, what will happen? It'll normally undergo refraction, right? But if I were to take this now, okay, let's put the medium. Let's put water on top and let's put air underneath. Right? What you will recognize here is that initially, as the ray moves from water to air, you'll recognize that refraction happening. Just see that there? As the ray moves from water to air, undergoing refraction. Right? But as the angle, watch it here, as the angle of incidence increases, there's a particular point when the ray no longer enters. There's a particular point when the ray no longer enters here. Right? And this angle equals to this angle. When that happens, what you're experiencing there is total internal reflection. Right? What you can see here, let's check out the angle here. Right, let's just check out the angle. What's the angle on the left side? Are looking like about 35, 40, 50. Looking like 50 degrees. Right, let's check the next side out too. So this angle looking like 50, this angle also looking like 50. So the angle on both sides are equal. That's okay? So what you're experiencing there is total internal reflection. Right? The ray does not come out here, the ray is just totally internally reflected. Right? What are the conditions, Anya, for total internal reflection? Take it with. What are the two conditions for total internal reflection? Right? The angle of incidence is more than the critical angle, and right, and the ray in a denser medium. Right? Those two things must happen, right? Water is more dense than air, and this angle here is bigger than critical angle. Anybody remember what's critical angle? What's the critical angle, Nathan? What's the critical angle? When the angular refraction is 90. Let's see if we can use our experiment here and work it out. Anybody can see it? Watch it here, right? It might be a little hard to read off, but watch it here. So when you read this away, at that exact point is the total is your reflection. It's a critical angle. See that? at the exact, sorry, a little before that, right around there. That's the total length. That's your critical angle. Right, you can't really see it so good because they're not putting it along the boundary, they're removing it. Okay, but what you're observing there is total internal reflection, right? And if I continue to make the angles bigger, you'll still experience total internal reflection. All right, let's change it to glass now. Let's change it to glass. Right, I have a question. Can you help me find the critical angle for glass? What's the point of critical angle? Sine inverse 1 over refractive index. Do my favor now. Use the refractive index of glass and tell me what you get in the critical angle. Okay. Right, how much you all got? 42? 42? So any angle bigger than 42, what will happen? Any angle bigger than 42, total internal reflection. Okay, so watch it here. Right now the angle is about 30. Right now the angle is about 30. As soon as I reach, here's 40. Coming down, 41. Coming to about 42 around here. So what happened? It will disappear. Okay? But okay with that? All right. So those are the conditions there for total internal reflection, right? So let's take a look at a little scenario here. I have a total internal reflection in a triangular prism. Total internal reflection in a triangular prism. Right? So here we have a triangular glass prism. And we know that the critical angle is 42 degrees, right? So we're going to do all of the maths here. Let's say we have a triangular prism and here is 45 degrees. Here is 45. So here's how much? How much is here? Here's 45 as well, right? That's okay. So I am going to let a ray come in here, Leonardo, and we have to figure out what will happen to that ray. All right, Leandro. So we have to figure out what will happen to that ray. So as the ray enters, let's label it up. A, B, C. Let's label it up, right? First thing I want to do, draw a diagram and see if you remember where to put the normal. See if you remember where to put the normal. Draw this. See if you remember where to put the normal, right? We'll start with Ali, just pronounce the first name from again. Ijaz, right? Ijaz, we'll start with you. See if we can figure out where the normal is, right? Oh yeah. Physics for this week will be Tuesday at 5 o'clock. And I have that meeting at 5 o'clock. Tuesday 5. Hello. Hello. Good enough. How about it? Yeah. Tuesday 5 o'clock, right? I will send you the link. In fact, in case I forget to add someone to the group, this is the link, right? Right? That's the online link. Right? It's on Zoom. Right? On Tuesday, it'll be on Zoom. Because next week, Saturday, because I'm a stream of 4 nights, I wouldn't do a physical class on Saturday. All right? Right, make a note of that. Once I add all, I'll message all of it. Just in case I don't add all. I might forget. Right. Where is the normal Ijaz? Where is the normal? This is the point of incidence right here. So always remember the normal is that 90 degrees at the point of incidence to the surface. That's the surface, so 90 degrees is there. Okay, this is the surface, point 90 degrees. That's okay? You okay with that? Right, I need some help. What will happen to that ray? That ray is traveling along the normal. What will happen to it? Come back down, refract, nothing. Up. By not changing boundaries. It's still on the it's still kind of boundary here. Right? So once a ray on the normal, right? Once a ray on the normal, what is the angle of incidence? What's the angle of incidence? 0. Times 0 is 0. So it means that if the angle of incidence is 0, the angle of refraction is also 0. So, right, I'll give you the worded note just now, right? Whenever a ray travels along the normal, nothing will happen to it. It's undeviated. So the ray will just pass straight through here. Right? The ray will just go straight through. But when it reaches here now, I want you to draw the normal. I want you to draw the normal at that point and tell me here's 90, right? What is the angle inside it? What's the angle of incidence? Draw the normal at the point AC and see if you can figure out what the angle of incidence. Draw the normal. Remember, the normal is 90 degrees at the point of incidence. How about the angle inside between the normal and the right, Ashton? Where's the normal, Ashton? Where's the normal? How to draw it? Up? I can't draw it up, no. You have to be specific. At the point is what? Just draw it up like that. Dotted now, very specific. Right? We can't just draw it like this. We can't just draw it like that randomly. Right? There is something specific we have to do. 90 degrees at the point of incidence. Right? At this point, 90 degrees to the surface. That's okay? So this is the surface, 90 degrees. I want you now to figure out what's the angle here. What's the angle from here to here? Your little mass. From right here to right here. Not here to here, here to here. What's the angle there? Right, try and figure out the angle there. And then we'll figure out what will happen to the ray. Right. So what angle we got? Right, here is 45, here is 90. So here is 45. So here is also 45. Here is 45, here is 90, here is 45. And because here to here is 90, it means that this angle here is 45. Right? Please remember, here's air and here's glass. So where is more dense? Glass is more dense, right? Nice. Glass is more dense. So what do you think will happen to the ray then? Huh? What do you think will happen to the ray? It will where? Here? Try and describe it to me. Bend. I'll give that particular word. Bend is the word. Huh? It will refract. So it'll come out here. What will happen to it? That's the word. One is more than that, it's more than reflect. It will what? We're doing it topic. It will totally internally reflect. Right? So watch here. Here's what happening here. The rays in glass is more dense than air, right? And the two conditions are what? You must be in the denser medium, and this angle here is 45, right? So the first rule is you must be in denser medium, right? So the ray in denser medium. Second thing, the angle is what? 45, right? 45 degrees is more than the critical angle, 42. Since these two things happen, total internal reflection will occur. Total internal reflection. So therefore, if here is 45, this angle here is how much? Angle here is how much? 45. Right? So my final question to upside down. What will happen to the ray when it reaches? What will happen to the ray when it reaches there? What you would say the upside down? Come away then. All right, go to normal, and then you might figure it out. Huh? Right, so where normal is? You want to come and draw it? Come where to put it normal. Exactly where to put it normal. That's the normal, right? So when the ray reaches here, what will happen? Think about what happened here. It would go straight through. Right? Remember that? The ray will travel along the normal. Okay? The ray will continue to go straight through undeviated. Are you okay with that? So in summary, what happened to this ray? This ray turned 90 degrees. You're seeing that? Copy down and let me give you a notes. Actually, I'm going to make all try to write it. Your own notes what happened here. And next time, copy it down and I'm going to give you a note, right? 3 steps. What happened at AB, AC, and BC? We have to explain what happened at each base. No, but I'm called. No, that's not. Ready? At the surface AB, at the surface AB, at the surface AB, the ray travels along the normal and is undeviated. The ray travels along the normal and is undeviated. Stop. When it reaches the surface AC, when it reaches the surface AC, it undergoes total internal reflection. It undergoes total internal reflection. Undergoes total internal reflection. Since write these 2 things here. Write those 2 things there. Since the rays in the denser medium and the 45 degrees more than the 42 degrees. .45 degrees is more than the 42 degrees. First up, as it travels to the surface BC, as it travels to the surface BC, as it travels to the surface BC, it is again undeviated. It is again undeviated. First up, right? The ray has now bent through 90 degrees. The ray has now bent through 90 degrees. The ray has now bent through 90 degrees. Right? So in this question, we bent the ray bent 90 degrees. What you're gonna do for me now, think about it. You're using this same triangular prism, and I want you to bend it through 180 degrees. So you're using 1 prism, not 2. Right? Actually, I can make it use 2 and 1. Yeah. I want you to show me two waves. One with two triangles, one with two, and one with one. I want you to bend the ray not 90 degrees, but 180. Right? And I want you to use two rays, and I want you to, two prisms and one prism. Huh? No, you gotta put in labels. I just want to see how you put in the prisms. Bend it through 180 degrees. And I want you to do it two ways, with two prisms and one prism. Right? This is all I want upside down. I want it like that. 90 and 90, that's 180. That's all they're doing. Figure out how to bend the ray like that. Two methods, using two prisms and using one prism. Oh yeah, try it. And I'll bring in on the board to do it. Right? I will pick on I'll tell you I'll pick on this one. Pick on Joy. Well, the connection was sleepy down maybe. Yeah, try that one. Bend it to 180 using two and using one. We had to figure out how to angle it. Right, with two should be easier. The hard one is with one alone. Get it? Get it? Yeah. It's Leonardo, right? Yeah. Figure out any? You figure out this one? Two other? Nice. But take a little look, see that now. I'm going to figure out one already here. We have to read them now. I'll see. If the read. So where do you want it to do? No, you put it up there. Put it up the new one thing. Only hard one. Yes. I think I'm going to go one here, but I want to go but you can see one. So you have it here. But I wait, John. All right, I see. If you join, that's the answer. Why you have two under? Why you have two under one other complex number? Joy, right? That one. That's one. What's the big stuff? When it grows up, right? This way you come. This one you come down inside. Yeah. So it will come from here, right? And where you want to do? Right. Okay. Come here. Go this way, right? How you do that? How you put it? Come back here. Yeah. Do the next one, right? How you have this? Yeah. Two prisms. Yeah. They use two prisms and then one prism. Yeah. You figure out one. So you figure out one. Right, so some people figured out this one here. So the ray will come here, it will totally internally reflect, will come through here, totally internally reflect again. Right? That's the one with two triangular prisms. But it could also be done at one prism. So you can take the one prism and angle it like this. The ray come in here, here, here. Okay? Right? All okay with that? Let's do it. Let's do a little past paper now. Right, take a little read, try this here. What year is it? I don't know what year it's on. Right, the refractive index of water is 4 and 3. Write that down, please. The refractive index of water is 4 and 3. Right, the refractive index of water is 4 and 3. Work out part 1 and then I'll go to part 2. The refractive index is your one has hard copy your past papers to write it, other one. Yeah. So you can kind of go to past papers and just start to write. So it's have two types, a cheap one and one that you can actually. I would say. It's have one big like this on Mr. Marlon. And it's have a shrink version. But the one like this is like full paper they could write it. The one that shrink is how to squeeze it in here. But I want one like this. But these expensive, but it's like 100. I'll tell you. Okay, let's give it enough. Come on. Try that there, find the critical angle. Please remember the refractive index is 4 and 3, right? I just give it up. Right? The refractive index of water is 4 and 3. How you work out the critical angle in part 1. Look back at the formula. Okay, you ready? After you find the critical angle, we have something after. What happens to the ray if the angle of incidence is 68? Everybody will get a critical angle? Formula there? Or no? And then write it back for your sine inverse 1 on n. Explain what happens if the angle of incidence is 68. I'll come back to the diagram, right? What will happen if the angle of incidence is 68 degrees? Write it down, then I'll work it out. But you probably do enjoy a little diagram in the question, eh? We're not sure what year it is. Ready? Let's see what you got now. So part one, they asked us to find the critical angle. So the critical angle, is sine inverse 1 on n. So it's sine inverse 4 and 3. How much you all got? 40, like 49, 48.6, right? Right. And explain what happens to the angle of incidence is 60. So number one, the ray is in water. Right? So the ray is denser medium. And number two, the angle of incidence is more than the critical angle. That's okay? 68 is more than 48.6. So what does that mean? Total internal reflection will occur. Are you okay with that? Total internal reflection will occur. Total internal reflection will occur. Allez, voilà. Ijaz. Allez, let's try next one. Do a little thing there. a little tricky. Think about it. So you had to figure out how T and TB related. How they related? That's part one on top. Determine how angle A and angle B, how are they related? We have maths there, right? Plenty maths up. Plenty maths here. Huh? How are they related? Any ideas? There's more maths than physics in the first part, right? Any ideas, Maria? Well, I need to have some ideas, Maria. We need to get some ideas. Anybody have any ideas? Focus on this little corner here. Focus on that little corner there. Now, you're not sure if it's 45 to be anything. Yeah? Kiran, you have an idea? You have an idea there? It's more maths than physics. You need numbers. Here is 90 for sure, right? Here is 90 for sure. Correct? So how much is here? No, you don't know what theta B is. You don't know what theta B is. Regardless of what theta B is, what here is? How much less than 90? You can create some kind of equation. Huh? Okay, if theta B was 30, if theta B was 30, that angle on top there is what? Right? So basically the angle on top there is what? 90 minus theta B, right? Correct? Yeah? And what is the total angle here? 90. That equals to 90. But and this total angle here is 90. So if I added 90 minus theta B and I added to theta A, that whole thing is 90, and yeah. And if I add this piece here to this piece here, and that whole thing is 90, do all those maths and some what you get it? Plenty maths. Plenty maths there. Do all those maths and some what you get it? Huh? Work it out and see. Let me work it out for you because I feel already that maths thing right now. Right? Let's say I move 90 across here. I'll get minus theta B plus theta A is 90 minus 90. Correct? 90 minus 90 is 0. So minus theta B plus theta A is 0. And I'm going to move theta B across the equal sign. So I'll get theta A is equal to theta B. I know you say it equal, but you can't just say it equal, you have to show them how, right? So they're equal. Both angles are equal. Both angles are equal. You might kind of see the 0 there. You might see the 0 there. Right? So theta A and theta B are equal. So, right, but there's a real hard one. I pick a hard one there. Right, Nuria? Let's see if we can finish up this one then. What condition? So we said that theta A is equal to theta B, right? What condition must theta B satisfy in order that the total internal reflection occurs at AB. Theta B has to be, well, the ring already any more dense, but what about the angle? More than theta A? Missing something. Make it helpful. It must be more than the critical angle. It must be more than the critical angle. Okay? Theta B must be more than the critical angle. That's the action. Right? So the only way total internal flexion can happen is if theta B is more than the critical angle. Right? Theta B and theta A the same thing, right? And you might see it there. You might see it here. In our example here, if here was 40, how much here will be? Here will be 40, here will be 50, so here will be 40. Will total internal reflection happen? If here is 40, will total internal reflection happen? No. Because 40 is less than 42. That's okay? So the answer is theta B must be more than the critical angle. All right? Let's go easier one. Let's do an easier one and you'll come up one by one, I'll correct it. Yeah. Okay, when I will come and I'll correct it. Try this one here. Draw the ray, try and figure it out. Draw the ray, yeah? Draw a diagram and find the angle of refraction. They gave you the refractive index of 1.5. Oh yeah. Yeah, let's find the angular refraction on thing, right? All right. What y'all got? 5 more minutes. All right. 5 more minutes. Please be careful. Try it normal. Find your angle instead. Right? All right, let's see what you come up with now. Right, so in order for us to get the angular refraction, number one, we had to draw a normal and find the angle of incidence. And then we using Snell's law. Remember this? To find R, and then you rearrange the formula, right? Here is 1.5 is equal to sine 45 over sine R. Cross multiply and sine and solve for R. R is sine inverse sine 45 over 1.5. How much you got there? I got 20.1. Anybody else got that? Yeah? No, you got that? 28.1? Why no, yeah. Right. Given that the critical angle for glass is 41.8, deduce whether or not total internal will happen at PQ. So you have to draw an exact value. 28.1 is like right here. Here is 28. I just put in 28, right? Here's where your math skills will come in on it. Right? Here is 28. So how much is here? How much is up there? Anya, how much is there? Here is 28. So how much is here? How? This whole thing is 90. So it's 28, 90 minus 28, right? So that's how much? 62. How much is up here earlier? How much is up here? 45, because here's 45, here's 90, so here's 45. Last piece of math. How much is here? What? 73. Are you okay with that? So you see what math said to get all the angles? So Ashton, what's the last angle here? What's the last angle there? So this little piece here. And this whole thing here is how much? 90. So how much you'll get here? Yeah, so 17, right? Yes. Right. 17 degrees. So if the angle of incidence, if the angle of incidence is 17 degrees, right? And yeah, will total internal reflection happen? No. So what would happen to the ray? It will refract out. It will not come here. It will refract out. That's okay? So the answer is total internal reflection will not happen because the angle of incidence is smaller than 41.8. Up? How is to get the angle? In your head. So what is something in your head too? You have to work it out. You have to show them the angle. You have to show them that it's less than 40, 41.8. All right? Anya, bye-bye. Bye-bye. Why not sure about how I get the angle? Right? How much is? I'm going to show you over again, right? Here is 45, right? Here is 28, correct? So how much is here? Here is 90. So that'll be 90 minus 28, right? Which is 62. If here is 45, here is also 45. And then 180 minus these two will give us 73. Correct? So you draw a normal here. 90 minus 73 is 17. 17 and less than the critical angle. So therefore, no total internal reflection. All right. Remember, our next class is Tuesday, 5 o'clock. I'll message on the group to remind you, right? I'll message